So in the last video, we learned about distance versus displacement. Now today we will add time to the picture, and that one change gives us speed, velocity and acceleration. Now here's a question to start. A car and a bike both travel 100 kilometers. The car takes 1 hour and the bike takes 4 hours. They cover the same distance. So what is the difference? So the difference is exactly what this video is about. So by the end, you will know the difference between speed and velocity, what acceleration really means, all three formulas, and you will solve numericals on each. So let's begin. So this is about speed, velocity, and acceleration, as you can see on the screen. Now, what is speed?
Speed tells us how fast something moves. It's how much distance you cover in a certain time. So,
This is the speed. Speed is distance over time. How much distance you covered in how much time. So if you cover 100 kilometers in 2 hours, so you took 2 hours to cover 100 kilometers. So your speed is 100 by 2, which is 50 kilometers per hour. So basically, speed is telling us how fast something is moving, how fast you are covering any distance. Okay. The unit for this is meter per second, and since we only care about how fast it moves, it's about magnitude, and that's why it's a scalar quantity. Okay. So notice that speed is using distance and time. So in the last video we learned about distance, and now when we added time to it, basically how much distance and how much time, it becomes speed. Okay. So it's not. So back to our example, car covers 100 kilometer in 1 hour and bike covers 100 kilometer in 4 hours. What are the speeds? So we'll calculate speed using distance over time. So speed is distance over time. For car, it's 100 kilometer. The distance is 100 kilometer and time is 1 hour. So it's 100 kilometer per hour. For bike, the distance is still the same 100 kilometer, but the time becomes 4 hours. So it's 100 by 4, which is 25 kilometers per hour. So the speed of the car is more because it covers this same distance in lesser amount of time. You're going from point A to B in lesser amount of time, so your speed is more. This is what speed is. Now, one more thing. In real life, speed keeps on changing. You will not necessarily travel from point A to B in same speed, right? Your speed might change at any point. So that's why in real life we use average speed. What was your average speed throughout the journey, not at any point. At any point, if you measure, it becomes instantaneous velocity speed. It becomes instantaneous speed. So we'll learn about that in upcoming videos. But in this video, you should learn about average speed. So average speed is the total distance traveled from point A to B in total time taken. So that is the average speed. Okay. Okay. So this is the speed. Now let's move to velocity. What is velocity? The key line of velocity is that velocity is also speed, but it also gives us direction. Just like distance and displacement. Distance is how much you travel. Displacement was how much you travel in which direction. Similarly, speed and velocity. Speed is what is your speed. Velocity is what is your speed and in which direction. So it's a vector quantity. So velocity is displacement over time, and unit is meter per second. Same, and it's a vector quantity because it's giving us magnitude and direction both. So as you can see, the speed is using distance and velocity is using displacement. So since speed is using distance, velocity is using displacement. Speed is also scalar quantity like distance. Velocity is also a vector quantity as displacement. They come in matching pairs. Okay, so so note this: the speed is asking how fast, velocity is asking how fast and which way. Now let's learn about acceleration. So acceleration is when velocity changes, we have acceleration. It's the rate of change of velocity with time. So velocity, as we learn about velocity is basically how fast and in which direction. So if so that will not remain constant every time, right? The speed in the velocity will change, the direction will change. So that will give rise to acceleration. So acceleration is basically difference in the velocities between 2 points, the time taken to make that difference. So basically final velocity minus initial velocity divided by time. So acceleration is change in velocity over time. Okay. Now so the, since it has magnitude and direction both, again it's a vector quantity and the unit is meter per second square. Now, one important thing to note is from this formula, you can see that acceleration is v minus u by t. So let's say if v is greater than u, which means the final velocity is greater than the initial velocity. So the acceleration will be positive, right? Which means acceleration is positive, which means that the body is speeding up, which means you started at a lower speed and you ended up at higher speed. So you accelerated up. Now let's say final velocity is less than initial velocity. So it means that the acceleration will be negative, which means that the body is slowed down or we can say retarded. So that's retardation. Retardation is negative acceleration, which means slowing down of an object. Okay, now one more question here. Why is the unit meter per second square? Why is the second squared? We saw in the speed, we saw in velocity that the unit was meter per second, but why in acceleration the second is squared? So here's the explanation. Since velocity and speed were distance over time, distance is meter and time is second. So it's meter per second, but acceleration is velocity by time. Now, velocity is itself is change of speed over time. So velocity is distance over time, which is meter per second, and then we are taking average over time for the acceleration. So that's how the meter per second square comes up. So it so we can look at it like how fast your speed is changing over time, or we can look at it as how much your speed is changing over time. And so this is acceleration. Let's say a car is traveling 60 km east in 1 hour, then 60 km back west in 1 hour. Find A. Average speed, find B. Average velocity. So what we learned till now? We learned that the average speed is basically total distance traveled 120 km. Now what is the time taken? Time taken is 1 plus 1, 2 hour. Then what will be the average speed? Average speed will be 120 by 2, which is 60 km per hour. Okay. Now, when we talk about velocity, remember we talk about displacement. We learned that we talk about displacement. So first we have to find what is the displacement. In the last video we learned that displacement is the length. Displacement is the straight line between starting point till the final point. So here, the car is traveling from point A to east 60 km and then back to west 60 km. So finally the car will be at the same position, right? So initial point is 0, final point is also 0. So the displacement will be 0. So it travels 60 east, 60 west. It it got displaced by 0 km. Okay, so the time remains same to us. So final acceleration will be final average velocity will be 0. Is that clear? I hope it's clear. So now we will look upon one more example. So a bus starts from rest and reaches 20 meter per second in 5 seconds. Find its acceleration. So bus starts from rest. So what do we have from this question? We have the final velocity, 20 meter per second. We have 5 seconds. We are being asked about acceleration. Now we learn what is acceleration. Acceleration is change in velocity over time. Change in velocity is final velocity minus initial velocity. So final velocity is 20 meter per second. Oh, but we don't have initial velocity. So how do we solve this question? Oh, wait. If you read it again, the question says that a bus starts from rest So this is something which we need to keep in mind while reading the question. So it's saying that the bus starts from rest. What does that mean? The bus was stationary. So the bus initial velocity was zero. So we have everything to calculate acceleration. We have final velocity which is 20 meter per second. We have initial velocity which is zero. And we have time 5 seconds. So what is acceleration? Final velocity minus initial velocity over time. 20 minus 0 over 5, which is 4 meter per second square. So we have acceleration, which is 4 meter per second square. A train is slow from 30 meter per second to 10 meter per second in 4 seconds. Find its acceleration. Is it positive or negative? Let me know its answer in comment. I'll try to reply to all the comments. Please subscribe, like, and share. And don't forget to comment the answer. We'll meet in the next video with upcoming concepts. Thank you.